we're going to consider a series, call it S. If S equals to the series x raised to I from I equals to 0 till n, show that x times S would equal to the series x raised to I, whereby I would equal to 1 till n plus 1. S minus x times S equals to 1 minus x raised to n plus 1. And that S would equal to 1 minus x raised to n plus 1 divided by 1 minus x. To solve this problem, let's begin with the initial sum S. We multiply x to both sides of the equation and observe how the series changes. So we write the series in its expanded form. So we'll have in brackets x raised to 0 plus x raised to 1 plus x raised to 2 plus x raised to 3 and so on and so forth until x raised to n minus 1 plus x raised to n. And outside the brackets, we have x multiplied with this series. Opening the brackets, we get x times 1 plus x squared plus x cubed plus x to the power of 4 plus so on and so forth till x to the power of n plus x to the power of n plus 1. So basically, all the exponents of our series has been raised by 1. Meaning, if we were to rewrite our resultant expression in a summation notation, we would get x raised to I, whereby I would equal to 1 up till n plus 1. And this proves our first question. Now moving on to our second question, we can prove this by investigating s minus x times s, since we have already formulated what x times s should be. So if we rewrite both series in their expanded forms, we find that all terms with the exception of x raised to 0 and x raised to n plus 1 gets cancelled off. And we know that x raised to 0 is 1. So we have 1 minus x raised to n plus 1. And the second question is proven. Now moving on to the third question from here, if you notice on the left hand side, we can pull out s, leaving in brackets 1 minus x. Shifting 1 minus x to the right hand side, we get 1 minus x raised to n plus 1 divided by 1 minus x. And our third question is solved. If you like that solution, leave us your comment. Also, like, share, subscribe, and tune in for more videos in time. For more math problems with solutions, go to mathofit.com. Alternatively, you can come straight to the Mathofit YouTube channel and check out all the available math videos to date.